In section 9-5, you're going to learn how to solve yet another way. Maybe what we should do is make sure and review the different ways that you have solved. Okay? How have you solved? You have learned how to solve number 1 by graphing. That was the first thing. You have also learned how to solve number 2 by solving, let's put solving for x squared. And number 3, you've learned how to solve by factoring. So today you have yet another way. You're going to learn how to solve by completing the square. Now, nobody really likes completing the square, but the next thing that I teach you about, you can't learn in 9-6, it's called the quadratic formula. The quadratic formula would never exist without completing the square. So we have to learn it whether you want to or not. Now let's take a look at this one. How would we solve this one if it was set equal to 0? Well, you would break it apart and either use guess and check or the book way. I'd like to use guess and check. 2x and x, I would try 3 and 5. This one would be a minus and this one would be a plus, so that I get a minus 5x and a plus 6 to make my plus. And again, you could use the book way instead of guess and check. You would then set each one equal to 0, just like you did in section 9-4. And you would solve. On this one, you'd get a positive 5 over 2. And on this one, you would get a negative 3. So we have learned how to solve by factoring. But look at this one. Can you think of any way to factor this? Absolutely not. There's no factors of negative 15 that would ever give you that positive 1 in the middle. So today is going to help you solve problems like this when you can't factor. So let's up here at the top say, use when can't factor. Alright. Today you will learn how to solve things that you don't know how to factor. You can use this method even if the problem's factor, but we just usually don't if the problem is really annoying. It doesn't factor. I would never complete the square if I knew how to factor something. It's just that annoying. In general, you can change the expression x squared plus bx into a perfect square trinomial by adding the quantity b over 2 squared to x squared plus bx. This process is called completing the square. The process is the same, whether b is negative or positive. Let's start slowly. Before we even begin, what is an example of a trinomial that is a perfect square? You guys remember those special cases that we had? Take a look at this one. Why would this one be considered a perfect square? Because it factors down into x plus 3, the quantity squared. Okay? Now why would this one, let's try another one. Why would that one not be a perfect square? Because it does not factor down to the exact same two things. So this one is not a perfect square, this one is a perfect square. Look at the first type of problem we have, finding c. Now that would be the last number to complete the square. This is just what, look at the directions, what value would complete the square. So what is the value of c so that you have x squared minus 16x plus something to be a perfect square trinomial? Well, here's your steps. You take your middle term, negative 16, and you divide it by 2, and then you square it. So that's really negative 8 squared, which is a positive 64. So they're asking what value would complete the square? C would be 64. Alright, let's try again. Just very slowly. We aren't fully using completing the square, we're just practicing how to complete it at this moment. So what would c have to be so that it would be a perfect square? Well, you take half of your middle term, 20 divided by 2, and you square it. So that's really 10 squared. So what would c have to be? C would have to be 100. Alright, now let's go ahead and go next. What to do if there's an equal sign and I'm asked to solve. I'm going to walk you through these as step by step as I can. Alright, so take a look at this problem. X squared minus 14x plus 16 equals 0. Step 1. Well, maybe you should make a couple of notes. This does not factor. You could try, but you won't get it. You guys have never learned how to solve something that doesn't factor. So watch the steps very carefully to complete the square. Step 1. Get x squared and x on the same side. Okay, get x squared and x on the same side, and the constant on the other. So in our problem, I'm going to subtract 16 from both sides. So you get x squared minus 14x equals negative 16. Step 2. Take 1/2 of the x term. Okay, that is going to be 1/2 or negative 14 over 2, which equals negative 7. Step 3, you're going to square that. So you're going to do negative 7 squared. You're going to get 49. Step 4, you are going to add that number to both sides to keep it balanced. Okay. So you're going to have now x squared minus 14x plus 49 equals negative 16 plus 49. Okay, step 5. Step 5, you need to factor. You need to factor this side here that I'm pointing at, the left side. You need to factor it into a perfect square, and then you need to combine your like terms on the right. So we're going to write factor and combine. Okay, so draw an arrow. Now you have to remember how this factors. And if you're not sure, the nice little hint is that step 2 can help you with step 5. So step 2, we knew that the middle term is going to be a negative 7. So watch what we're going to do here. We're going to do x negative 7, or x minus 7 squared, equals 49 plus negative 16 is 33. Now if you're not sure why it's negative 7, I'd like you to take a moment, pause the video, and prove that x minus 7 times x minus 7 does in fact equal this trinomial above it. If you don't take the time to understand this, this whole lesson is going to make sense to you. So you're going to multiply your binomials together, and you should prove that it does equals x squared minus 14 plus 49. And this is an x here on that 14. I never put that on. Put that x on that 14 in the middle. Okay, step 6. Step 6 is to square root both sides. So if I square root this side, I get x minus 7. If I square root 33, I get plus or minus the square root of 33, because there really is no perfect square root in 33, so I stop there. Step 7, add or subtract your constant. So I'm going to draw an arrow over. Now you see this 7? That means I have to add 7, add 7. So I get x equals, now please don't put that 7 and make that 40, because that's in the square root and 7's not. So what we're going to have is a positive 7 plus and minus the square root of 33. So what you should get used to is, since I haven't taught you how to reduce square roots yet, we're going to get 2 decimals. I know I did say the word decimals. When they're not perfect squares, it's what you're going to have to do for right now. So we'll do 7 plus the square root of 33 is 12.7. So x equals 12.7 when we add. And minus the square root of 33 is 1.3. And those are the 2 x values that if you took them, now remember we had to round, but if you took these 2 x values and plugged them in up here, you would get, each time, whether you plugged in 12.7 or 1.3, you would get a 0 at the very end.